In this example, we're told the sine of x is equal to a half and the cosine of x is greater than 0. So we're looking for our answers to be in a quadrant in which sine is positive and cosine is positive, so that means that we're in quadrant 1 and all 6 trig functions are going to be positive. Now there are several different ways that we could work this problem, but since we're practicing on identities, we're going to attempt to work the problem that way. So first of all, I'm trying to find all 6 trig functions. Sine of x is a half. The cosecant of x is the reciprocal of sine, so I know the cosecant of x is going to be 2. To find the cosine of x, I could use my Pythagorean identity, which says that the sine squared plus the cosine squared is equal to 1. So 1/2 squared plus whatever the cosine squared has to equal 1. A half squared is a fourth. So 1/4 plus the cosine squared of x is equal to 1. That means that the cosine squared of x is equal to 1 minus a fourth, which is 3/4. So the cosine of x is equal to the square root of 3/4, which would be the square root of 3 over 2. So our cosine of x is equal to the square root of 3 over 2. Secant of x is the reciprocal of cosine. So if I invert that fraction, I'm going to have 2 over the square root of 3, which rationalizing will give us the answer of 2 square roots of 3 over 3. And so what's left is to find my tangent and my cotangent. Tangent is equal to sine divided by cosine. That's one of our quotient identities. So our sine was equal to a half. Our cosine was equal to the square root of 3 over 2. So if we flip and multiply, 1/2 times 2 over the square root of 3, the 2's would cancel and we would end up with 1 over the square root of 3, which again, let's rationalize. And we're going to end up with the square root of 3 over 3. Cotangent is the reciprocal of tangent. So if we take the reciprocal of this function, we get the square root of 3. And there are our 6 trig functions, giving that the sine of x is a half and the cosine is positive, using identities to come up with the answers.